All right, strap in, everyone, because today we're going on a deep dive
Deep down.
into the quantum realm. We're going to be exploring something called nanodiamonds.
Tiny, tiny diamonds.
You sent us some seriously cool research about how these microscopic diamonds are being used for bioimaging.
And quantum sensing, some really cutting-edge stuff.
Yeah, I was blown away by what I read. We're talking about diamonds so small they can operate, wait for it,
Within individual cells.
revealing information at the quantum level, no less.
Exactly.
Before we get ahead of ourselves, let's back up a bit for our listeners. The research you sent over, this was from Okayama University, right?
Yes, scientists over there have made a major breakthrough.
A breakthrough. Tell me more.
They've found a way to seriously boost the performance of these nanodiamonds.
Okay, color me intrigued.
It means we can do things like track a single drug molecule in the body.
Whoa, hold on. We're getting a little ahead of ourselves here. Before we jump into the breakthrough, I need a little quantum nanodiamonds 101.
Okay, sure.
What exactly are these things, and how in the world do they work?
Okay, so picture this. A diamond.
Got it. Sparkly. Expensive.
Right, but now shrink it down
Shrink it down.
to a size thousands of times smaller than a human hair. That's a nanodiamond. And inside this nanodiamond, we create a teeny tiny defect.
A defect. Now that doesn't sound very high-tech.
But it is, trust me, this defect is called a nitrogen-vacancy center,
Nitrogen-vacancy center.
or NV center for short. It's this defect that's the key to the whole thing. You see, when you shine a light on an NV center,
Shine a light on it, okay?
it emits photons. And those photons, well, they carry information about the NV center's spin state.
Spin state.
Yeah, like a tiny little compass needle pointing up or down. And the cool part is that spin state is super sensitive to its surroundings.
Sensitive how?
It can detect magnetic fields, electric fields, even temperature, all at a super tiny scale.
So by analyzing the light coming out of the nanodiamond, you can basically tell what's going on around it?
Exactly.
At an insanely small scale. That's pretty amazing.
It is.
But hold on, if these things are going inside the body, I can't help but think, diamonds. Isn't that a problem?
That's what's so cool about them. Nanodiamonds are biocompatible,
Biocompatible.
meaning they don't harm living cells.
So they're like tiny, harmless spies that can sneak into the body.
Exactly. They can give us a look inside the body that we've never had before.
Okay, now I'm really starting to see the potential here. For bioimaging especially, this is huge.
Absolutely. Think about it. Being able to track what's happening inside individual cells.
That could totally change healthcare as we know it.
You got it. We could be talking about personalized medicine, treatments tailored to your cell's responses in real time.
Wow. Or what about detecting diseases like, let's say, Alzheimer's, years before any symptoms even show up?
You're catching on. That's the kind of future we're talking about with nanodiamonds.
Okay, I'm definitely sold on the concept now. But, and you know there's always a but, I read somewhere that there have been challenges with using nanodiamonds in bioimaging. Something about their spin quality not being good enough. Can you explain that a bit?
So yeah, there have been some hurdles, you're right. The thing is, the nanodiamond needs to hold on to its quantum state long enough for us to get accurate readings.
Okay.
But sometimes impurities, even inside the nanodiamond itself, can mess that up.
Impurities.
Yeah, little imperfections, or even just jostling around at the surface of the nanodiamond, anything that disrupts that super delicate spin state.
I see. So it's a signal to noise problem, right?
Yeah,
Too much interference and you lose the information you're trying to get.
you got it. And that's where our friends at Okayama University come in. They found a way to create high-quality nanodiamonds
High quality.
with spin properties comparable to way bigger diamonds.
Wait, so they've basically managed to make these tiny diamonds much better at holding onto their quantum state.
Precisely.
How in the world did they pull that off?
Okay, so they started with these incredibly pure diamonds, single crystal diamonds enriched with carbon-12.
Carbon-12. Okay.
Then they very carefully introduced just the right amount of nitrogen to make the NV centers.
Interesting. So they were super careful about minimizing any impurities right from the start.
You got it. Total quality control from the ground up.
Clever. So what then? They shrink these diamonds down somehow.
Exactly. After making those NV centers, they crushed the diamonds down to nanodiamond size.
That's crushed.
Yep, and then suspended them in water. And get this, the spin quality improvements, they were pretty remarkable.
Okay, I gotta know. What kind of improvements are we talking about? Give me the juicy details.
First off, these new nanodiamonds are bright.
Bright.
They emit a ton of photons, which is awesome for bioimaging,
Okay, why is that?
because you need a strong signal to see what's going on inside those cells. But the really important part is this. Their spin relaxation times. They're way longer.
Spin relaxation times, meaning?
It's like they can stay in tune for much longer. They're more reliable for sensing.
So longer spin times, brighter signal? Sounds like a winning combo to me.
It is, and there's more. These nanodiamonds also need less microwave power to detect their spin state.
Okay, why is that good?
For bioimaging, you don't want to blast those cells with too much radiation. Less power is safer.
Makes sense. So they're potentially safer to use in living systems.
Exactly.
This is pretty impressive stuff. But have these souped-up nanodiamonds actually been tested in living cells? This isn't all just theoretical, right?
Nope, not theoretical at all.
Ah.
They put them to the test. They took those nanodiamonds and introduced them into HeLa cells.
HeLa cells.
Yeah, they're a type of human cell used a lot in research.
Gotcha.
The nanodiamonds performed amazingly. Even inside a bustling, busy cell, they were easy to see, produced a clear signal.
No way.
And they even proved that they can sense tiny temperature changes right inside those cells.
So they passed their first live test with flying colors. That's incredible. It sounds like we're talking about a whole new level of precision for bioimaging.
Absolutely. A whole new level of sensitivity. And remember, this is just the start.
Just the start. There's more.
Oh, yeah. We've talked about bioimaging, but these nanodiamonds have a ton of other uses. Applications that go way beyond healthcare.
Okay, now you've really got me hooked. Let's move beyond the body and see what else these tiny diamonds can do.
Get ready, because things are about to get really interesting. We're talking about everything from smartphones to batteries, even quantum computers.
Bring it on. I can't wait to hear more.
Okay, so we've explored how nanodiamonds can revolutionize healthcare. But let's shift gears for a bit.
Okay, where are we headed now?
Let's zoom out from the human body and into the world of tech.
All right, my phone could definitely use some upgrading.
I hear you. But seriously, these nanodiamonds, they have the potential to change the gadgets we use every day.
Okay, color me intrigued. Tell me more. How do tiny diamonds fit into smartphones and laptops and all that?
Well, think about all those sensors that make our devices work.
You mean like in smartphones and laptops?
Exactly, in cars and even spacecraft. Nanodiamonds could make those sensors way more sensitive, way more efficient.
Okay. So potentially we're talking about even more responsive touch screens.
Yes.
Super accurate GPS.
Uh-huh.
Maybe even phones that never need charging. Okay, now I'm really interested.
Uh-huh. Well, maybe not eternal battery life, but definitely a step in the right direction. Nanodiamonds can actually help us get more juice out of our batteries.
Okay, now that's something I think everyone wants.
Right. Imagine sensors in your battery that can monitor its health constantly.
Constantly.
Yeah, like in real time, identifying tiny little issues before they even become a problem.
So you're saying longer lasting batteries.
Longer lasting and safer batteries for everything, electric cars, laptops, phones, everything.
Wow. Okay, so less range anxiety when I'm on a road trip. No more frantic searches for a charger when my phone's at 2%. What else can these nanodiamonds do? This is why.
Get ready for this one, because they could actually play a key role in something pretty futuristic. Quantum computers.
Quantum computers. I feel like that's straight out of Star Trek.
It kind of is, but it's becoming more and more real.
Okay, so for those of us who aren't like super techie, break it down for me. Why is quantum computing such a big deal?
Imagine being able to solve problems in seconds that would take normal computers, the ones we use now.
Yeah.
Billions of years to solve.
Billions with a B.
That's the potential power of quantum computing. We could revolutionize everything.
Everything? Like what?
Drug discovery, material science, artificial intelligence. It's mind-blowing. And these tiny diamonds, these nanodiamonds, could be the key to making it all happen.
I'm trying to wrap my head around this. We're talking about a whole new level of computing power.
Exactly.
Potentially solving some of humanity's biggest challenges. That's pretty incredible.
It is.
It also makes me think about, well, the environmental impact of all this. I mean, are we just trading one set of problems for another?
That's a great point and a really important question to ask with any new technology. The good news is nanodiamonds aren't just about fancy gadgets and supercomputers.
Okay, so there's more.
They can also be an amazing tool for environmental management.
Okay. How do tiny diamonds help us, clean up the planet? I'm not seeing the connection.
Think about it this way. They can be used to create sensors.
Sensors, okay.
But these are super, super sensitive sensors. Ones that can detect even the tiniest amounts of pollutants in water and air.
Okay, that's pretty impressive.
It's like an early warning system for the environment,
Yeah.
We can pinpoint pollution hotspots before they become big problems.
So not just measuring pollution after it's happened, but actually getting ahead of it.
Exactly. And that leads to protecting ecosystems and ensuring that everyone has access to clean water and clean air.
So it's not all just about, like, fancy tech advancements. It's also about using this tech to create a healthier planet.
I agree. And there's even more. Remember how we talked about targeted drug delivery in healthcare? Well, we can use that same idea for environmental cleanup.
Okay, how does that work?
We can use those nanodiamonds to deliver very specific substances.
Substances.
Yeah, the substances we need to neutralize pollutants. We deliver them right to the contaminated site.
So you're talking about, like, microscopic cleanup crews.
Exactly. They go right to the source of the pollution and neutralize it.
Like,
Incredible.
Wow, so we're talking about precision and control, not just in the body, but also in the environment.
It all comes back to precision and control. That's what makes these nanodiamonds so powerful, so exciting.
They offer a level of detail, a level of control that we just haven't had before.
And the potential applications.
Yeah.
They touch almost every aspect of our lives. It's truly remarkable.
I have to say, from bioimaging to quantum computing to environmental cleanup, these tiny diamonds are some serious overachievers.
They really are. And honestly, I think we're just scratching the surface.
You mean there's even more potential?
As research progresses, who knows what we'll discover.
This is amazing stuff. But before we get too carried away with all the possibilities, let's step back for a minute. We've talked a lot about the good stuff, the potential benefits, but are there any downsides to this technology? What challenges do we need to be aware of?
That's a great question, and an important one. Every new technology comes with its own set of considerations. Nanodiamonds are no different.
Okay, so let's talk about those considerations. I'm curious to hear your perspective. What do we need to be thinking about as we move forward with this technology?
Let's dive into that because there are some crucial factors to consider. It's important to approach this new technology with a balanced view, with our eyes wide open.
Okay, so we've learned that nanodiamonds have this incredible potential to revolutionize so many fields. Healthcare, quantum computing, even environmental cleanup.
They really are tiny powerhouses.
But as with any emerging technology, we need to proceed with caution. You mentioned that there are some challenges associated with nanodiamonds.
Right, we can't just ignore the potential downsides.
So let's talk about those. What are the big ones? What do we need to be aware of?
Well, one of the first things that comes to mind is scalability. Right now, producing these high-quality nanodiamonds happens mostly in labs.
Small scale.
Yeah, small batches. If we want to see all these amazing applications actually become a reality, we need to figure out how to produce them on a much larger scale.
So we've got the recipe, but we need to supersize it.
That's a good way to put it.
What else should we be thinking about?
Integration.
Integration.
Yeah, it's one thing to create these awesome nanodiamonds, but then the next step is figuring out how to actually integrate them into all sorts of existing technologies, or even developing brand new devices that can really take advantage of what they can do.
It's like having a super fast engine.
Yes.
But no car to put it in.
Exactly. You need the whole package. And then, of course, there's the cost factor. High-quality materials, cutting-edge fabrication, those things don't come cheap.
It makes sense. I guess for this technology to become truly widespread, we need to make it more affordable, more accessible.
Absolutely. Early adopters might be willing to pay a premium.
Sure.
But for it to really take off, the price needs to come down.
Okay. Anything else? Any other challenges?
Well, there's something that I think a lot of people don't think about, and that's standardization.
Standardization, what do you mean by that?
So right now, different research groups are using different methods for making and analyzing these nanodiamonds.
Ah, so everyone's kind of doing their own thing.
Right, which is great for initial exploration and innovation, but at some point, we need to get everyone on the same page.
So we need to develop some common standards.
Yes. Protocols, ways of measuring things so that results can be compared. It will help ensure consistent performance no matter what the application.
It sounds like, in a way, it's kind of like the Wild West out there right now.
Uh-huh. You could say that.
Lots of exciting potential, but also lots of work to do.
Exactly. It's important to be realistic, right? We shouldn't let the challenges overshadow the incredible possibilities that are out there.
But we also shouldn't underestimate how much effort is needed to really bring this technology to its full potential. It's going to take some serious collaboration.
Absolutely.
Yeah.
Scientists, engineers, policymakers, industry leaders,
Yeah.
Everyone needs to work together.
Okay, so I want to shift gears just a little bit here. We've talked a lot about the technical stuff.
Sure.
But what about the bigger picture? How do you see this technology shaping the future? Not just in specific applications, but its impact on society as a whole.
That's a great question. And I think it's a question that we're only just beginning to grapple with. But I do believe that we are at the very beginning of a new era,
The new era?
an era of precision, of control,
Control over what?
not just in the physical world, but also in the biological world, even the quantum realm.
Wow. Okay.
Nanodiamonds are just one example, but they really do provide a window into what might be possible, a future where we can interact with the world at a level of detail that, frankly, is hard to even imagine right now.
It's like we're getting a new set of eyes.
Mhm.
Eyes that allow us to see and manipulate things that we never even knew existed. It's exciting, but it's also a little bit scary, to be honest.
I agree. There's definitely a sense of awe, but also a need for responsibility. We need to be thoughtful, ethical in how we approach all of this. We need to make sure that these powerful tools are used to benefit humanity, to benefit the planet.
Well said.
Mm.
So as we wrap up our deep dive into the world of nanodiamonds, what's the one big takeaway you hope our listeners walk away with?
This is a journey, not a destination.
I like that.
We're at the beginning of something incredible. There's so much more to discover, so much to learn.
To everyone listening, stay curious, stay engaged, be part of this, be part of shaping this exciting future. And who knows what other amazing things are waiting to be uncovered right just below the surface. This has been an incredible exploration. We've seen how these tiny diamonds, these nanodiamonds, have the potential to touch just about every aspect of our lives, from healthcare to quantum computing to the health of our planet. Thanks for joining us on this journey of discovery. We'll see you next time on The Deep Dive.